If you own a truck powered by a Ford EcoBoost engine, or you are thinking about buying one, here is the truth you need to hear right now. Ford has finally admitted there is a serious cracking problem inside certain EcoBoost engines, and for 2027, they have engineered a real fix that truck owners have been demanding for years. This is not rumor. This is not just complaints on forums or one-off failures that got blown out of proportion. Engineers, mechanics, and industry insiders have been pointing at the same root cause for years. Structural stress, heat cycling, and material fatigue are cracking key engine components from the inside out. And here is the part that catches most owners completely off guard. The damage does not show up right away. It typically surfaces somewhere between 60,000 and 100,000 miles. And by the time it does, you are already staring at a very expensive repair bill with few options left. But here is where the story takes a turn. Because for 2027, Ford did not simply make minor adjustments and move on. They went back to the drawing board, identified the weak points, and rebuilt the design from the ground up. So let us walk through exactly what went wrong, why it took so long to surface, and what Ford has finally done to correct it. The EcoBoost engine family, particularly the variants found in the popular Ford F-150, earned a strong reputation for combining power with fuel efficiency. Turbocharging, direct injection, and a compact layout made it a modern engineering achievement. But when these engines were put under real-world conditions day after day, a hidden flaw began revealing itself. The core problem was cracks forming in cylinder heads, exhaust manifolds, and in the worst cases, the engine block itself. These were not random failures. They were the product of several factors working against the engine at the same time. First, turbochargers dramatically increase the heat generated inside the engine. More air and more fuel mean more combustion, and that means far more thermal stress on internal components. Second, everyday driving subjects the engine to constant heating and cooling cycles. Each time the engine warms up and cools back down, the metal expands and contracts. Over thousands of cycles, this weakens the structural integrity of critical parts. Third, certain areas of the engine were designed with stress concentrations that made them especially vulnerable, particularly around coolant passages and the points where turbochargers mount to the engine. One of the biggest reasons this problem created so much controversy is the timeline. These cracks do not develop overnight. They build slowly, hiding behind symptoms that are easy to dismiss. Small coolant loss without any visible puddle under the vehicle. Occasional overheating that seems minor at first. Rough startups on cold mornings. A little white smoke drifting from the exhaust. None of these signs scream major engine failure on their own. So many drivers kept going and kept ignoring the warning signals until the damage reached a point where there was no cheap way out. According to engine design specialists, the EcoBoost is not a bad engine. The problem is that it was engineered extremely close to its performance limits. Modern engines must satisfy multiple competing demands at once. Fuel efficiency, emissions compliance, and high output all have to coexist inside one compact package. Turbocharged small-displacement engines sit right at that intersection, and when engineering margins are that tight, real-world use can expose weaknesses that laboratory testing never fully captured. Thermal load density is a key part of the problem. EcoBoost engines produce significantly more heat per cubic inch than older naturally aspirated engines. That heat has to go somewhere, and over time, it degrades the metal around it. Cooling system margins were trimmed to maximize efficiency, but that left very little buffer when drivers were towing heavy loads or running hard in hot climates. Material thickness was also reduced to save weight and improve fuel economy. But thinner components become weak points under repeated thermal stress cycles. The engines that showed the highest rates of reported issues were the 3.5-liter EcoBoost V6, especially from earlier production years, and the 2.7-liter EcoBoost V6 across select model years. These powertrains are commonly found in the Ford F-150, Ford Expedition, and Ford Explorer. Not every single unit failed, but the pattern was consistent and widespread enough that mechanics and long-term owners began taking the situation very seriously. When cracks do form, the repair process is neither simple nor cheap. Outcomes range from cylinder head replacement to a full engine rebuild, to complete engine replacement. Minor repairs typically cost between $1,500 and $3,000. A major rebuild runs from $4,000 to $8,000 or more. Full engine replacement can reach between $8,000 and $12,000, and the timing of many of these failures, landing just past the end of warranty coverage, made the financial blow even harder for everyday owners who were not expecting it. Now for the part that changes the conversation entirely. For 2027, Ford Motor Company redesigned the critical weak points inside the EcoBoost. Rather than simply managing the symptoms, the engine block and cylinder heads have been reinforced using stronger materials and revised casting techniques that reduce stress concentration in the areas most prone to cracking. Coolant now flows more efficiently through the high heat zones, especially around the turbochargers. Updated thermal management software gives the engine computer smarter control over heat spikes during heavy load conditions. The turbo mounting design has been revised to reduce both vibration and heat transfer into sensitive surrounding components. Improved gasket and sealing technology also addresses the small leaks that often develop into much larger failures over time. Engineers describe this as a structural correction, not a patch. The old approach was managing heat and stress after the fact. The new approach eliminates the stress concentration points before they become a problem. The result is a longer engine lifespan, more reliable performance under towing conditions, lower long-term maintenance costs, and an engine that is no longer being pushed right to the edge of its structural limits every single day. For owners of existing EcoBoost trucks, the message is not panic, but awareness. Many of these engines run well past 150,000 miles without any issue. Monitoring coolant levels regularly, watching for any signs of overheating, using high-quality oil and changing it on schedule, avoiding hard acceleration when the engine is still cold, and getting a professional inspection at the first sign of unusual symptoms can all make a meaningful difference in how long your engine lasts. The EcoBoost cracking issue reflects a broader reality in today's automotive industry. As engines become more advanced and more stressed, real-world conditions sometimes reveal limits that simulations cannot predict. What Ford has done for 2027 signals that automakers are paying attention, identifying where those limits actually are and adjusting their designs to put durability back at the center of the equation. So, is the problem finally solved? The honest answer is yes. Ford appears to have genuinely addressed the root cause for 2027. Older engines still carry some risk. Maintenance still matters. And no engine is ever completely failure-proof. But for the first time in years, experts believe the EcoBoost platform is no longer operating on the edge of a structural cliff. The EcoBoost crack problem was never a myth. It was a real engineering challenge, rooted in heat, stress, and the hard limits of modern engine design. For 2027, Ford Motor Company did exactly what owners had been waiting for. They did not just acknowledge the issue, they fixed it at the source. And that decision could reshape the future of turbocharged truck engines for a long time to come.